Okay, 6.4 is a continuation of finding missing sides using trig, going back to our SOHCAHTOA, setting up our ratios and solving for an equation. But we're also going to add finding a missing angle. So if I only give you the right angle, how do we find the measure of those two acute angles also in the triangle? So when we look at this, we're going to focus on finding the missing side or sides and then the missing angles also. So right here we talked about in 6.3, we looked at using SOHCAHTOA. S is for sine, C is for cosine, T is for tangent. We know our ratios for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So continue setting up those equations, multiplying or dividing, and solving for that missing side length. Now, if we have to find the missing angle, looking right here at these, notice the ratios are still the same. With sine, it's still opposite over hypotenuse. But notice right here, and I'm going to zoom in there, you see that little -1. To find the measure of an angle, you have to take the inverse. So all it is a button in our calculator. So if you don't have a calculator, I want you to focus on just setting up the equations. If you have a calculator with access to that, then you can plug it in, okay? So we're really going to focus on the equation part of it, and then if you have a calculator, great, plug it in. If you don't, then we will make that work when you come back to class. Okay, so looking here, we know 2 of our 3 sides of this triangle. We also are going to have to look for angle A and angle C. So we're going to write all those steps down. So let's start with finding angle A first. So I'm going to circle angle A and focus my attention there. I know that the 100 is opposite, so that's the side opposite of angle A, and 84 is next to it, so that's my adjacent side. So knowing that I have O and A means that I have to use my tangent equation, and I'm just going to write that ratio there, okay? So to find angle A, what we're going to do is say tangent with our inverse, and then we're going to replace O and A with the numbers that were given. So instead of O, we're going to put 100. Instead of A, we're going to put 84. And then all you have to do is literally type that into the calculator. So I'm going to zoom in and show you what buttons you would push. So the first button you would push would be second. Let me change that to red so it's a little easier to see. Second. And then our tangent, you can see right above there, there's that inverse. And then 100 divided by 84. So 100 divided by 84 is what it would look like. And in your screen, you would see something like this. Oops. Tangent with the inverse, and it will open up parentheses, 100 divided by 84, and you would close parentheses. So if you want to go ahead and write that down in that calculator screen, you can, or over to the side. That way you know exactly how to type that into the calculator when you have a calculator in front of you. If you were to type that in, you always want to round angles to the nearest degree. So angle A would equal 50 degrees. Okay, let's go ahead and find angle C. This is really easy because we know in a right triangle, one angle is always going to equal 90, which means the other two have to equal 90. So to find angle C, all we have to do is take 90 minus 50, and that gives us 40 degrees. Okay, now we're going to look at finding the length of side AC. I'm going to change colors here. We always ask ourselves, do we have a right triangle? Yes. Do we know 2 of the 3 sides? Yes. And if we do, then we can use Pythagorean Theorem. We don't have to worry about trig here. So we can say that 84 and 100 are our legs, so that's our A and our B. So we can say 84 squared plus 100 squared equals our C squared because we're missing the hypotenuse. If we were to do 84 squared plus 100 squared in the calculator and then square root it, we would get 130. And it says to round to the nearest thousandth, so 3 places past would be 0.599. And that would be side AC. So we just kind of have to look at what's given. Do we have any of the angles? Do we not? Do we have any of the sides? And go from there. So let's look at another one. Let's look at example 2. We can see that we have one acute angle here, and we're missing angle D. So that's going to be really easy to find. We also only know one side, so we know we're going to have to use trig to find that missing side. So let's start with finding measure of angle D. Again, we know that F and D, because the right triangle, have to add up to 90 degrees. So all we have to do is say 90 minus 58, and that gives us a measure of 32 degrees. So that's D. I would advise not putting it in your picture because we want to just use the 58 that's there. We can use the 32, that's fine, but it just makes less busy work on our picture, less to worry about. So now, let's go ahead and find side EF. Doesn't matter which one you find first, okay? So let's find side EF. Well, if I'm going to use my 58, remember we talked about always circling the angle that we're doing the opposite adjacent hypotenuse perspective from. We can see that 14 is opposite. We're looking for EF. That's our adjacent side. We only want to label two at a time. O and A means we're going to use tangent. So we can set up our equation. Tangent of 58 degrees, that's the angle we chose, equals, and then our ratio, O over A. O is 14. We're looking for the A, so that would be our X value. Now again, if you don't have access to a calculator right now, we're just going to write the equation and talk about the calculator. When you get back into class, you can type that into the calculator. So because X is in the denominator divide, so we would switch these two places right here. Remember, we talked about this when we did 6-3. We would say X equals 14 divided by the tangent of 58. And we would literally type that into our calculator. 14 divided by tangent of 58. So if you're like, what does that look like? Here's your screen. We would say 14, let me change colors. 14 divided by, and you would hit the tangent button, just plain tangent, 58. And that way you don't have to worry about parentheses because it will open up a parentheses. You can close it, you don't have to, but that's all you have to type in. And so if you type that in, and rounded to the nearest thousandth, we would get 8.748. All right, let's do the last side, DF. Now you have two options once you get to that last side. Now we know two sides, so you can use Pythagorean Theorem, but if you don't like to deal with those decimals with Pythagorean Theorem, then let's go ahead and use trig just to practice that again. We already know the 14. We're looking for side DF, so I'm going to label in a different color so we can see the difference. 14 still the O because we're using the 58. DF is our H for hypotenuse, so O and H means we're going to use sine. So we would say the sine of 58 degrees equals O over H. So 14, you can put H there, you can put X there. Doesn't really matter. If you'd like to stick with your OA and H there, that works too. So again, we can see we're looking for the denominator divide, switch those two places, and we would type in X equals, or we would look at X equals 14 divided by the sine of 58. Remember, I should have said this at the beginning, remember your calculator has to be in degree mode for this to work. So remember, you would just hit mode and then choose degrees. If you type that in, 14 divided by sine of 58, kind of like we did the last one, you would get 16.508. Okay, let's look at the next one. So now we have to think about our picture here. We've got a 12-foot ladder placed against a wall so that the base of the ladder was 4 feet from the wall. How high up on the building would it reach? And what angle will the ladder make with the ground? Okay, so let's think about this in terms of a picture for a minute. We know we have a wall there. That's going to be your vertical line. We've got a ladder, which represents your hypotenuse, unless you're talking about a slide. And so we're looking for the height, but we were given the base. So we know that it is going to be a right triangle. So we have a 12-foot ladder, so let's put that where the ladder goes on the hypotenuse. It was 4 feet from the wall. How high up would it reach? So that's what we're looking for there, but then it also says what angle will the ladder make with the ground? Well, if it's talking about ladder and ground, We know that we're looking for this angle right here in red, and we use our theta symbol if we're missing an angle. So an X goes for sides, theta symbols go for angles. Okay, so we have to find two things. The missing side, the height of the building, and then the angle that the ladder makes with the ground. So let's start with the angle. Okay, we can highlight. We know we're looking for the perspective of theta. So we can label that 4 is our adjacent side, 12 is our hypotenuse. A and H means we're going to use cosine. But remember, because we're doing an angle, we have to do the inverse. So inverse cosine A, which is 4, over H, are 12. And you can simplify that, or you can just leave it as 4 over 12. That's fine. Plug that in, round to the nearest whole number, and we would get 71 degrees. We don't have to find the other angle because it's only asking for the angle that it makes with the ground. So now we can move on to the missing side. Again, think, do we have to use trig here? We know two sides, so we can go straight to Pythagorean Theorem. So 4 could be our A still. We're missing the B, and 12 is our hypotenuse, so that has to be the C. We would subtract here because we're missing a leg, so 12 squared minus 4 squared, square root that, and round it to the nearest thousandth. It would be 11.314. So there's our two pieces of information that we're missing. Okay, let's look at the next one. We've got a telephone pole broke 4 feet from the bottom. So that telephone pole is breaking. So if you need kind of a visual of this, we have this telephone pole. Here's the ground. And it broke right here 4 feet from the bottom. The top of it fell and is laying on the ground now. Okay, so there's you a visual. If the top of the pole landed 3 feet from the base, so think top of the pole is right here and the base is right here, that distance will be 3. It wants to know how tall was the pole originally. So if we stood it back up, so we need that hypotenuse to stand it back up and add 4 to it. And then what angle did the top of the pole make with the ground? So again, our theta is right there. Okay, let's go ahead and find the angle first. We're going to highlight our theta and label. We know that 4 is opposite. 3 is next to it, adjacent. We know we're missing the hypotenuse, so it has to be the O and the A. So O and A means tangent. So because we're looking for an angle, remember we have to use our inverse. Tangent ratio is O over A, so 4 over 3. And if we plug that into the calculator, second tangent, 4 divided by 3, round to the nearest whole number, and we would get 53 degrees. Now we're missing the side. We know two sides, so we know we can use Pythagorean Theorem. 3 and 4 are A and our B, so 3 squared plus 4 squared equals our C squared. Hopefully you realize that that's a triple. If not, plug it into your calculator. 3 squared plus 4 squared, square root that, and we know that C is going to equal 5. But 5 is not the final answer. 5 will go here. But remember, the question is, how tall was the pole originally? So we have to take the part that's still in the ground, the 4, plus the part that fell, and we know that it was 9 feet originally. All right, last one. Stephen is tying a tent down so that it will not blow away. He will attach a rope from the top of the tent to a stake in the ground. So that right there is going to represent your hypotenuse when you draw it, sorry. If the tent is 5 feet tall, we know tall is the same thing as height, so that will be your vertical leg. And he has a 12-foot rope. The rope is your hypotenuse. How far away should he place a stake in the ground so that the rope is long enough? So remember, your stake is right here in the ground. We're looking for this horizontal leg. We also need to find which angle the rope made with the ground, so that's where theta goes. Okay, so here we go. Let's find our angle first. We are going to highlight theta and label. 5 is opposite. 12 is your hypotenuse, so O and H means we're going to use sine. But again, we're doing the angle, so inverse sine. Open up parentheses, O over H, 5 over 12. Plug that into the calculator, second sine, 5 divided by 12, round to the nearest whole number, which gives you 25 degrees. All right, we need to find that bottom side. Do we know 2 of our 3 sides? Yes, so we can use Pythagorean Theorem. 5 would be your A. We don't know the B. And 12 would be your C. So in this one, because we're looking for a leg, we would have to subtract 12 squared minus 5 squared, square root, and B would equal, to the nearest thousandth, 10.909. And that answers both of our questions. So just remember, write down what you have. Think about what you're looking for. If you're looking for an angle, you have to use the inverse, a little -1. If you're looking for a side, see if you can use Pythagorean Theorem first. If not, then go to trig, set up your equations, and solve.